From the model, the boat is laid out on what we call a loft. And on this loft is drawn the various sections of the boat, which are represented by these frames which have been constructed in accordance therewith. This shows the frame sections from the bow to the step of the boat. And we are about to show you how these are put in place, and then we will have a general outline of the structure, the interior structure of this ship. These really represent what might be called the ribs of a man. Of course, these boats are not called men, they're called sheaves, but they all have ribs. And now we will show you just how they're put in place. As this is to be a high-speed boat, and we hope it will be the fastest boat in the world, we're going to show you how much speed you can put into the structure of a boat. This puts me in mind somewhat of the activity of the building of Miss America the 7th. Miss America the 6th was broke up in a test run several years ago, just 2 weeks before the Harmsworth race. And our men were called upon to build a boat in 2 weeks' time. The Miss America the 7th was produced in just 2 weeks' time. She was redesigned from the old 6th and built up, complete, the engine installed, and we won a race with that boat in that short space of time. And this is the way we do it. Now you can see the form which these frames build up. This is the general shape of the boat. A little later we will show you the general shape of the bottom of the front plane. You're now looking at the bow of the Miss America 10th and the bottom of the forward plane. It's very essential that this forward plane be a certain shape and have a certain relation with the after plane of the boat. Of course, we do not show you the after plane now. We will show that a little later. But the one thing we must be very careful of, these two planes are in synchronism with one another to keep the boat from porpoising and obtain the speed that we expect to get. This view shows the interior view of the forward part of the boat and the frames that support the front plane. When you consider the tremendous weight that is going to be carried by this plane, it's not surprising that such a tremendous structure must be provided. The total weight of the boat will be somewhere in the neighborhood of 14,000 pounds. 14,000 pounds being hurled at possibly 120 miles an hour must have some real rigid structure to, while the weight, the punishment that it gets is on the front end. This boat has a length of 38 feet, and an extreme beam adds materially to the structure, holding the plank seams together. When the boat is running in a rough sea, there is more or less bending of the hull, and the seams of the plank would work loose unless they were rigidly secured. The longitudinal plank of mahogany, even though only 3/16 of an inch thick, add very materially to the strength of the structure, bearing in mind that the sides of the boat act as a sort of bridge construction or truss to support the weight of the motors and other mechanisms. The plank being put on diagonally carry the grain of the wood in a diagonal direction so that when the longitudinal planks with a longitudinal grain are attached, the combination forms a very rigid structure. The first layer of planking also forms a background against which is placed a thickness of white canvas or silk sized with white lead to make the side watertight in case there should be cracks which would admit water. And over this canvas, the longitudinal planking is placed, which operation is shown complete in this view. It would take one well versed in naval architecture to understand just how we arrive at the design of the longitudinal planks. So they will fit when they are put in place to form the various curves and twists customary in a boat design. So I will only mention that after they have been laid out, they are sawed in their respective shapes in pairs similar to the frames, and one piece goes on either side of the boat so that when they are all in place, they form a balanced unit. The process of building the boat up to this time has been carried on with the boat right side up, just as she would ride in the water, but it becomes difficult to apply the bottom in this position. It is now necessary to give her a barrel roll, as the aviator would put it, and the application of the bottom planking is made very much easier by this procedure. After the boat is turned over and the boys begin work on the bottom, you will observe that the motion picture camera has stimulated to a marked degree the activity of the men. Just note the speed at which they are putting on the canvas. And what an idea! Just keep the cameraman ever present. It is imperative that the material used in the bottom of the boat be exceedingly strong to take care of the tremendous pounding and drag from the water. This will be readily understood when it is realized that the great power used in these boats, some 6,400 horsepower, is practically all absorbed by the skin friction of the water against the bottom surface. Experience has taught that the water will actually rub the wood fiber right out of the place, and we have found it necessary to make a careful microscopic examination of each board, selecting each piece so that the fiber is smoothed down by the water action rather than being rubbed up, as would happen if you rubbed your hair the wrong way. The material selected for the bottom of Miss America the Ninth required the examination of some 80,000 feet of Philippine mahogany, but it was well worth the effort, for this boat's bottom is as good today after all her hard running as it was when it was put on. Miss America the 10th is so designed that her forward plane, which carries most of the weight, some 7.5 tons, can be varied if necessary to secure the proper balance so that the boat will plane as high as possible and yet not porpoise or jump. The plane is of duralium, 8 feet long, and the full width of the bottom, extending from the step forward, is held in place by long bolts, and to change its angle, we release the bolts, shim up between the bottom of the hull and the metal plane the desired amount, and then secure the bolts, a matter of 4 or 5 hours' work.